So hello guys, today we are going to do a Leetcode problem. The complexity of the problem or the difficulty of the problem is of level easy. So if we go to the problem statement that says if we go to the problem statement as we always do. So the problem statement says given the head of a singly linked list, return the middle node of the linked list. Okay, so what the question is saying, given the head of a singly linked list, return the middle node of the linked list. Okay, so we are given the head of the linked list, singly linked list. So what are singly linked list? If anyone doesn't know what a linked list is, so linked list is just basically data that is stored by that is like a chain. This is like a chain where each each of these boxes is called a node. Is called a node that is linked by a linker. So all these data boxes, no matter where they are present in the memory, no matter where they are present in the memory, they can be linked to one another. They can be linked to one another. Suppose if I am accessing a data storage, and if I want to store one data here, one data here, and one data here, so I would make a linked list in which I would include this as the first node, this as the second node, and this as a third node, and I would connect them using a linker, using a pointer. Okay, so the linked list node contains two values, that is pointer to the next node, and the data that is stored. Okay, so if I want to connect, suppose if I want to connect this point to this point, I want to tie a string around it, tie a string between them so that they could be connected. So both of these points should be connected by a string, and this string contains a data. Consider this point as a node that consists of pointer as well as the data. So this data can be of any format, and the pointer points to the data node, the next data node, that also has a pointer that points to the next data node. Now this pointer, if the data node is at the end of the linked list, so this pointer points to a null value. By default, this pointer points to a null value. If we don't assign this pointer to a null value by default it will point to a memory location, and no one knows what that memory location is gonna be. No one knows what that memory location is gonna be. Why? Because we are not explicitly what the memory location is gonna be specifying what the memory location is gonna be. So it can point to any location. So this can lead to a hazard. Why? Because maybe it points to some location, and if I want to modify the content at this location, so maybe this location is also accessed by a game or by any browser. So if I am illegally pointing to this location by this node, so it makes an error. It raises an error. It makes or raises an error that this is not right. This is not right. I'm not accepting this. The compilers are not accepting this. So the good practice is to explicitly define the connection. Explicitly define the connection. So, as the name suggests, if I want to summarize what I told about the linked list, it contains of nodes that are linked together. So linked and a list. The list which is linked together by a linker is known as a linked list. We call it as a linked list. Okay. It consists of a data and a pointer to the next node. Okay, so this is all about linked list. This is all the conceptual thing about the linked list. Okay, and one more thing. What is the head? Head is the first node of the linked list. The first node of the linked list is called the head by convention. Okay, and the last node of the linked list is known as the tail. So the last node is known as the tail and the first node is known as the head. Okay, this you need to remember for solving the question, because if you don't know what the head is, you don't know where what is given. You don't know what is given. So head means we are given the first node of the linked list. Okay, so we have to return the middle node of the linked list. If there are two middle nodes, return the second middle node. Okay, okay, I understand. So if I take the first test case, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and if I say what I have to return, so I say that I'll count the number of nodes. The very basic approach, very basic approach that I'll follow is very basic approach that I'll follow is I'll make a temp pointer and a point and a counter. I'll make a temp pointer and a counter, and I'll initialize the counter to 0, and I'll point the temp to the head position. Okay, I'll point the temp to the head position, and as I go, I'll increment the counter. I'll increment the temp value. I'll make the temp value to go over the next temp value, next node, to go over the next node. And as I go over to the next node, I'll make the counter to increase the count. I'll make the counter to increase its count, and I'll just simply count the number of nodes. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. So in this, the number of nodes are 5, and if I divide it by 2, I'll get it 2. Because 5 divided by 2 in computer, it is by default, it is floor of 2.5. So we get it as 2. We get it as 2. As simple as that. So if I use the indexing, okay, if I use the zero based indexing, so 0, 1, 2, 3, 4, and the total nodes are 5, so this 2 is my middle element. As we were given, this 3 is the middle element. Okay, so the very basic approach that I showed you is that the very basic approach that I showed you is that I'll count the number of nodes, I'll divide it by 2, and then I'll traverse once for getting the count, and second time I'll traverse to the position of count by 2, because I know that count by 2 gives me the middle element. Okay, count by 2 gives me the middle element. So third, okay, so if I order them by indexes, so 0, 1, 2, 3, 4, 5. Okay, so third is my middle element. That is to say, if even in case of even, the middle node is gonna be what the middle node is gonna be. Middle node is gonna be the second mid node. Middle node is gonna be the second mid node. Okay, and middle node is gonna be the second mid node, and in for even cases, for odd cases, the middle node we will exactly get, because 5 divided by 2 gives me 2. So there is no like ambiguity in this statement. So if I come to the algo once again, what I have to do, I'll first count all the nodes. I'll consider whether it is even or it is odd, and I'll go again from the head to the position where my count is present, where my iterator count becomes equal to the counter, and when it becomes equal to the counter, I'll return that particular node. For example, in this case, I'll return a 4, the fourth node. I'll return the fourth node. Okay, so this is my very brute force solution in which uh, I'll count the nodes. Suppose you are given an example that you are given 6 people. You are given 6 people. P1, P2, P3, P4, P5, P6. Okay. Suppose you give 6 people and someone tells you to find the middle element. Someone tells you to find the middle element. Now what you will do, you will start by counting from P1. You'll count as for 0. When you go to P1, it becomes 1. When you go to P2, it becomes 2. When you go to P3, it becomes 3. When you go to P4, it becomes 4. When you go to P5, it becomes 5. When you go to P6, it becomes 6. So you know that total number of nodes present is 6. I'll divide simply by 2 and get the 3 as a result. As we know, we'll use zero-based indexing. So I'll return the third node. How I can return the third node? I can't come back from here. So what I'll have to do, I'll have to reset the pointer position to head. I'll have to reset the pointer position to head, and then I have to go all the way through to the third node and then return this node. I'll return the third node. Okay, so in this question, what my time complexity would be? What my time complexity would be? As you are counting the number of nodes in the first iteration, as you are counting the number of nodes in the first iteration, counting the number of nodes in the first iteration. So, as you're counting the number of nodes in the first iteration, that makes the time complexity is O of n already. And now I want to know. I want to traverse it back again to return that specific middle node. And what if my middle node is the last element? What if I suppose that my middle element is the last element? Okay, so for that case, I'll have to move it through O of n again. So what my time complexity becomes? O of n of 1 for one time traversal plus O of n. That becomes 2 into O of n. Okay, 2 into O of n. Okay, that's a high complexity for such a simple problem. Okay, so I'll tell you the better approach. Better approach is, suppose I am given with this node 1, 2, 3, 4, 5. I'm given this nodes 1, 2, 3, 4, 5. And if I tell you that I'll make two pointers, one is the fast pointer and one is the slow pointer. Now, what is the work of the fast and the slow pointer? Okay, I'll point them both to slow, both to the head. This is basically head, nothing but the head of the linked list. It contains a data 1. Okay, so I'll point both of them to the head node, and what I say, I'll move both fast and slow at the same time at the same iteration. But I'll make the fast pointer move two places ahead. I'll make the fast pointer I'll make the fast pointer move two places ahead. I'll make the fast pointer move two places ahead in one move, and I'll make the slow pointer to move one place ahead in one move. Okay, so my fast pointer in one move goes to the third position from, if I consider zero based indexing, 0, 1, 2, 3, 4. So my fast pointer goes to from 0 to 2 directly. So my fast pointer goes to from 0 to 2 directly, and my slow pointer goes to the first node directly, whereas my fast pointer is one step ahead. Okay, so from second node, if I consider the second iteration, so the fast pointer would now move to the fifth node, whereas the slow pointer would move to the middle node, that is from this node. Slow pointer would move from second node to the third node, this node that contains the data 3. So this when my fast pointer is at the last position and my slow pointer is at the middle one, I'm getting this scenario in which if I go any further, then my fast pointer would be out of bound because I can't go beyond this. If I go beyond this, my fast pointer will not move, because like if I in the next iteration this would be pointing to a null position, and I can't access the next node from a null position. Because the null position already null. and it doesn't contain any next pointer. So okay, so I have to make sure when my fast pointer, I have to make sure when my fast pointer comes to the last node, I have to stop it, because if it goes any further, then it will return a null result. It will return a null result. It will return a null result. Null result. It will return a null result. Okay. So when my first pointer is at the last position, my slow pointer is here. What I can slowly observe is that if anyone walks for suppose anyone walks for 6 nodes, if my fast pointer suppose if my fast pointer walks for 6 nodes, then my slow pointer would eventually walk then my slow pointer would eventually walk 3 nodes. That is common sense, right? Because if someone is walking at 2x speed of mine, okay, suppose he covers 2x distance, or let's consider another scenario, the opposite one. Okay, suppose I am walking at the speed of x meter per second. I am walking at the speed of x meter per second. So in 1 second I'll cover x meter. But if someone else is moving at the speed of 2x meter per second, then he'll cover 2x distance. That is double of me. So what I can observe is the fast pointer moves 2x distance than me. So it means that when it has covered the 2x distance, I'll be at the x distance. Okay. If I apply the same thing here, then if we both start at the same time, one is slow and one is fast, and if the fast pointer that is moving the 2x speed of mine goes at the sixth node, then it's very obvious that I'll be standing at the third node. I will be standing at the third node. Okay, so we will not consider the slow pointer approach. We'll make the fast pointer to make the decision of iteration. It will travel 2 steps at once, whereas the slow pointer would travel 1 step at once. So the slow pointer would exactly be covering half the distance. As of covering half the distance of fast pointer. If I say my fast pointer is at 1, 2, 3, 4, 5. My fast pointer is at 5th position right now at the current instance. Okay, so where would my slow pointer would be? So I'll simply divide the fifth five. There are 5 nodes currently in this list. So I'll divide simply 5 by 2, 2.5. It becomes the floor of the value. So the slow value becomes 2. Slow pointer would be at the position 2 currently. That is what we need to find. What we need to find in this case, so if my fast is at last position, or if my fast is at a position, because it can happen that it can come at the fourth node and then at the null node directly. So This possibility can also happen. Like my fast is pointing at the null node, that is no it is pointing at nothing. So I can directly divide it by 2. I can directly divide it by 2 and get my slow pointer position. Get my slow pointer position. If I explain it that way, ki my fast pointer has covered 30 kilometer, then what would mine slow pointer would have covered? Slow pointer would have covered 15 kilometer. Okay, fast pointer 30 kilometers, so fast slow pointer would have covered 15 kilometers. That is so obvious, right? So I'll just apply this analogy to find the middle element. Find the middle element. If my fast pointer is here, then I'll simply divide the number of nodes covered till now by 2. Or like my slow pointer would be definitely here because my slow pointer moves x steps, whereas my fast pointer moves 2x steps. So as we can see, slow pointer is 2 of f. Fast pointer is 2 of s. यानी कि that means fast pointer covers 2s distance. So I can simply divide f by 2 to get the result. That is what I am doing in this case. Okay. So if I try to code this approach, I'll first I'll make a slow pointer that I'll point to null, and I'll make a fast pointer that will point to null. Okay, and I'll make the fast pointer as the judger, that I'll track the first pointer, and from the fast pointer I can easily get the position of the slow pointer. So there is no point in tracking the slow pointer. I'll just track the fast pointer. So if my fast pointer if my fast pointer if my fast pointer my fast pointer is at the last position or the end position, the end position. Okay, then I'll stop the iteration. Simply I'll stop the iteration. Okay, so I'll stop the iteration. Okay, so if I'll stop the iteration, so I'll just have to make sure. Okay, I'll have to make the fast pointer go as to a 2x speed, into 2x speed. So in one iteration, it would cover two steps, and in one iteration, the slow pointer would cover only one step. So I can easily see that the slow pointer would be at the x by 2th position as the fast pointer progresses. Okay, so I'll have to simply return slow, and you see the magic that slow pointer is exactly at half distance. So if fast pointer is at last position, I can easily say that the slow pointer is at the middle position. Okay, my slow pointer is at the middle position. If I try to run it, let's see what happens. If it causes any error, we'll fix it. Okay, so what I'll do next is so we are getting an error, right? So what I'm doing wrong, let's see from the start. I'm declaring a node, and I'll declaring while not of fast and not of next. Okay, so this is the error. Okay, so I'll move till fast is there, and the and fast of next exists. that means that means that the current node is present current node is present, and current uh, current nodes next is also present. That means if I am on the last node, I want the program to stop. So when my fast pointer is at the last node, my slow pointer would be at the middle node. Okay, so this is what I was doing wrong. So I'll go till fast and fast of next exists, and I'll make the slow pointer move one place, slow moves one place, and the fast pointer moves two places ahead. Okay, so fast covers 2x distance than me, so I cover x distance obviously. So I'll try to run it now. Okay, so now it works. I'll try to submit. Okay, so it works and it beats 100% of my users. C++. Okay, so this was the question. If I discuss the time complexity of the question right now, if I discuss the time complexity of the question, so the time complexity of the question would be O of n, O of n. But if there are n nodes, if there are n nodes, as I am traversing them by skipping one node, that means for 6 nodes I'll traverse only 3 times. For 5 nodes I'll traverse only 3 times. Yes, we'll traverse 3 times. From 1 to 3 to 5. Okay. For 8 nodes we'll traverse 4 times. That means for n nodes we'll traverse n by 2 times. That means the time complexity becomes O of n. No need of space complexity. Space we aren't using any extra space, so space complexity remains O of 1. So this was my lead code solution of the problem, middle of the linked list. Okay, hope you guys enjoyed the solution. Hope you guys understood what I trying to say. Okay, so if I want to summarize, what I taught, okay, so if I want to summarize what I taught, if someone moves, if I move x distance and someone move 2x distance, so I obviously move half distance than him. Okay, so if my fast pointer, if me and my friend is at the same position, and if my friend, if he's 2x faster than me and I move at x speed, if he moves at 2x speed, then obviously if he is at the last position, I will be at the middle position. Okay, so this is obvious. This is the intuition of that question. This is question, and this question approach is also known as the tortoise hare approach. Tortoise is the slow pointer and here is the fast pointer. Okay, so hope you guys enjoyed the solution. If you have any comments or any suggestions regarding the solution, you can post it in the comment section. And if you like the video, do share, subscribe, okay, and comment. Thank you guys, have a good day. Okay, bye.